With this video, I would like to explain and share some of my research and also share some findings of a recent study published in 2018 in the Journal of Applied Physiology about lifelong exercisers. And so a little bit about my research. One thing I have been doing last year is I worked with some colleagues at the University of Salamanca in Spain, and I'm continuing some of that research on exercise and physical activity in older adults. Some of the research I've been doing here at Cortland involves oxygen consumption and VO2. So I want to talk a little bit about my research. I want to talk a little bit about the history of exercise in the United States. And then number three, talk about this recent paper and the VO2 max of 70-year-olds and some of their conclusions from that paper on the benefits of lifelong exercise. So an outline of today's talk. So some of my research and typically what I do in the exercise physiology lab is to measure VO2. And VO2, not necessarily VO2 max, but VO2 is the metabolic cost of doing exercise. So how much oxygen is being used to do a certain kind of exercise. And how much means volume. So V is for volume, and of course O2 is for oxygen. So it's the volume of oxygen or O2 that is used for exercise, and it's also called oxygen consumption. And VO2 is usually measured, so the units are usually milliliters of O2 per kilogram body weight, so per body size, and then per minute. So mils of O2 per kg per minute. And the max VO2 is a good measurement of someone's aerobic fitness and cardiovascular health. So some of my research on VO2 is I've looked at the oxygen consumption using different kinds of equipment. So in our exercise physiology lab, we have a pretty unique kind of treadmill that can alter or change the amount of body weight that someone is using as they run on this treadmill. In another paper that I've posted in our class, we've looked at the VO2 using an eccentric training bicycle. So I've looked at the oxygen consumption of running or pedaling on different kinds of equipment. I've also looked at VO2 max of athletes, and either a VO2 max on the treadmill or a VO2 max on a bicycle, and also measured their efficiency or economy. So not at max, but at a sub-max pace, how economical they are at running and how efficient they are at pedaling. So in terms of how fast they're going, how much oxygen is being used. So some other research I do is on efficiency or economy of movement and economy of physical activity or of training or competition. And not here at Cortland, but some of my previous research has actually been animal research. So I've looked at the VO2 max of antelope, and I think I'll share that with you, and have measured rat studies and goat studies and mice studies. So not done here at Cortland, but some of my previous work has been looking at different animals. So a little bit about my research and my past research. And so number two of our outline was to look at a history of exercise in the United States. And this will be a brief history. And this will lead in actually to the paper that I've posted on lifelong exercisers. So about 50 years ago in the 70s, there was this boom in physical activity or exercise in the United States. And so why was that? And there's a couple reasons for this. And it's probably not one reason, it's a combination of all of these reasons. One reason, you may know this, is that in 1968, Catherine Switzer, who actually was up in Syracuse, and she actually was on the cross country team in Syracuse, but there wasn't a women's cross country team, so she ran with men. And the men's coach up there sort of challenged her to run Boston. So she signed up to run Boston Marathon, and she was the first woman to complete the Boston Marathon. And here's this classic picture of the organizer of the Boston Marathon and the Boston Athletic Club, maybe, that put on the Boston Marathon. Jumped out of the car that was following the racers and tried to pull her number off. But she completed that Boston Marathon, and she became pretty popular and started some exercise programs and marathon runs just for women. So this started around the 70s. Also in the 1972 Olympics, Frank Shorter of the United States won the gold medal, and this was on television and sort of ignited this running boom in the United States in the 70s. Also, some of you may know this, that Title IX was passed into law in 1972, and that no person in the United States shall, on the basis of sex, be excluded from participation in athletics or physical activity. So at least that was part of this law. And so there was more opportunities for girls and women to be more physically active and to participate in sports and athletics. Also around the 1970s, aerobic dance studios and aerobic videos became really popular. So there was this sort of boom in the United States around the 70s. People had more free time, had a little bit more money to spend. And so that was about 50 years ago. So a recent paper was published, and it looked at people that started exercising around 50 years ago. So they were about 20, and then they're now about 70. And they've continued to exercise over the last 50 years. So here's the VO2 max of 70-year-old individuals. So part three of this outline of this class today is to look at this recent paper, so the cardiovascular skeletal muscle health with lifelong exercisers. And it was a whole group that published this paper from Ball State University in Indiana. And this was recently published, so just 2018. And I'll ask you to skim this paper and just sort of look at the purpose and maybe a little bit about the methods. The next couple slides, I will try to explain the methods and some of the results. So the methods, they interviewed a lot of people. They found 68 individuals that were admitted to the study. And out of these 68 individuals, there were young exercisers. So they were about 20 years old or a little bit older, 10 males and 10 females. They were sort of the control, I guess. Then they also had lifelong exercisers. And they had 7 women, 7 females, and 21 males. Then they had older, healthy adults. So not lifelong exercisers, but still healthy adults, but about the same age group as these lifelong exercisers. And here there were 10 female and 10 males. So this next slide is some of the characteristics of these individuals as a table. And you can see this table in the paper that I've posted. So this table is for the women. And here's their age, height, weight, their body mass index, their percent body fat, and they tried to get an idea of how much physical activity they did just by counting the number of steps that they did per day for just a week or two before they got tested. And so if we look at this row, you would expect that the young exercisers, they did more steps than the lifelong exercisers, and for the older healthy adults. The big arrow that I put at the top of this table is the age. So the young exercisers are about 25. The lifelong exercisers, their average age was 72, and they had older healthy adults who were also about that same age, 75. So that was for the women. The next slide is for the men. And the men, they actually had an additional group. So for the men, they had young exercisers, YE. They had lifelong exercisers. But then they also had a performance group. So here were older men who were actually competitive. So they were training to compete in like age group races. So for their age group, they were trying to compete and win their age group. So they called those performance. Then they also had an older healthy group that were about the same age group and healthy, but had not been doing exercise or training. So let's look at the sort of characteristics of these men, both young and older men. So here's a table again, similar to the one for the women. Here's their age, height, weight, BMI, percent body fat, and again, steps per day. And let's look at the age on the top row again. So the young exercisers is same as the women, about 25 years old on average. All the men, 21 men, older men, were about the age of 74, and they were able to divide all these older men into a performance group. So that was 14. This was the group that was training to win races, like their age group of races. And then there were a group that were, they called fitness. So they weren't necessarily competing, yet they still had been physically active for 50 years. And that was 7 in that group, and they were about 75. And then an older, healthy adult group of 10 people who were also about 75 years old. So the men, they were able to divide up into this performance and fitness group. And then they tried to, the authors of this study tried to determine how hard they were working out. And this was subjective. So this is the intensity. And this is this next table. And I sort of made up this table, but this is from the paper. So these are for the women, and this is their lifelong average. And obviously that's sort of hard to figure out exactly, but it's self-reported intensity is light, moderate, or hard. So that was it, just 3 values of light, moderate, or hard. And then they tried to figure out about how many days per week they exercised. So this was the lifelong average, and the women about 4.6 days per week, about 6.5 hours per week, and at an intensity of 1.9. So this is the group that were the lifelong exercisers for the women. Now the same table is for the men. Remember, the men were divided up into a performance group and a fitness group. So these are the older adults. They were about 75 years old, but they had been exercising for the last 50 years. So here's the group for the older men. So here's the lifelong average for the performance group. So they worked out about 4.4 days per week, about 7.6 hours per week, at an intensity of 2.1. So remember, intensity was just 1, 2, or 3, like light, moderate, or hard. That was it. And this was self-reported. So these individuals had to sort of, decide how hard they thought they worked out. And this bottom table is for the fitness group. 4.6 days per week, about the same, a little bit less hours per week, and a little bit lower intensity than the performance group. That's what you would expect. So now let's look at some of the results in terms of VO2 max. So they measured their VO2 max, just what we can do in the exercise physiology lab at SUNY Cortland. They measured their VO2 max on a treadmill, and they looked at it over at different people's age. So here's a graph that shows this VO2 max, and I'll try to explain this graph. So first of all, this is for the women. So here are the women. On this left-hand side, y-axis, is their VO2 max. Remember, those units are mils of oxygen per kilogram body weight per minute. So that's their VO2 max. And then here on this x-axis is age. Okay, fine. Then also what they did in this graph, and what is shaded in the middle of the graph, is sort of normative values. So this dashed line would represent the 50th percentile, and the top of this shaded area would be the 90th percentile. The bottom would be the 10th percentile. And so if you look at your age group of about 20 or 25, let's say, the 50th percentile for 25-year-old women, their VO2 max is just above 30. Yeah. Okay, so that's what this graph means. So they remember for the women, they had young women who are about 25 years old, and that's shown by these gray shaded circles. And the young women VO2 maxes are 35, 45. Here's a couple high VO2 maxes of almost 60. So that is the young women exercisers. Now let's go out to the right-hand side of this graph, and here are the older women. So they are around, 70 to 75 years old. The older healthy women are shown by the black circles. And here are all the black circles, and their VO2 maxes are what, like 20-ish? And then let's look at the VO2 maxes for the lifelong exercisers. They're shown by these open circles. And here are their VO2 maxes, and certainly the open circles are on average like higher than these black circles. And actually, here's one woman, her VO2 max. Let's look at her specifically. She's what, about 70 years old? And her VO2 max is 35. So that's a VO2 max that actually that is about the same as some young women exercisers. That is pretty impressive. So that was for the women. Now this next graph is similar, and it's looking at the men. The only addition is to remember that the men have one additional group, which is a performance group. So here's the results for the men. It's the same kind of graph. It's VO2 max on the y-axis and age on the x-axis. And the same shaded in area in the middle of the graph. And for young men, your VO2 max on average, the 50th percentile is just above 40, like what, 43, 44, something like that. And so for the young exercisers, YE, that's sort of this light shaded circle. Yeah, it's, 40s, 50s. Here's some pretty good VO2 maxes of above 60. Now let's look at this big group of older men. So the older healthy men, they had not been doing lifelong exercise or training. That's shown by the black circles. And here are their VO2 maxes. They're about 75 years old, and their VO2 maxes are, whatever, 20-ish. Now let's look at the lifelong exercisers. And these were older men that had been doing exercise for 50 years, not necessarily competing, but still being physically active, and that's shown by the darker shaded square circles. And here were the 7 of those individuals, and on average, these are above the older, healthy men. Now let's look at these performance, lifelong exercisers that were training to try to win races. And that's these white circles, and they are certainly above the older, healthy men. And again, we can pick on one individual. Let's pick on this person. So he's about 70 years old, and his VO2 max is almost 45. So again, that's probably, the VO2 max of, 20 or 25-year-olds, and maybe even above VO2 maxes of 20, 25-year-olds. So that is pretty impressive. So some conclusions of this study, and this is interesting to think about, that the chronological age, so that's, the age in years, the women lifelong exercisers were 72, and all the men, so both the performance and the fitness men, were 74. So that chronological age is not going to change, obviously. That's from when they were born. But their physiological age, their VO2 max, that was the graphs that I'd shown before, their heart rates or the power they could generate, their physiological ages, we can just look at those numbers, are, 40-year-olds or 40 to 30 and 40 to upper 40s. So if you want to get younger, you can't change this chronological age. You can change this physiological age. So very impressive. And that's a lifelong exercisers. And it's a challenge to get young people. Some of you I know are physical education majors. It's a challenge to get young people to continue to exercise for 50 years. But if you can get them interested in being physically active, they'll continue to do it. And same if you have clients in a gym, or you're doing training or doing rehabilitation with people, we've got to get people to be physically active. So some of the paper conclusions, the physiological age of these lifelong exercisers was 40-ish. And one part of the graph, and I'll show this again, was that a higher VO2 max resulted in less dependence and less risk of mortality, less risk of death. So what does this dependence mean? And a higher VO2 max can be a cushion for disease or for surgery or for other health problems. So I tried to make my own graph similar to what was shown on the graphs from the paper. And here's my own graph. And here's a VO2 max in mils per kg per minute on the y-axis, and here's age in years. And I didn't really highlight it, but in those previous graphs from the paper, they had a dashed line that they called independence or dependence. So if someone is below that dashed line, that means that their aerobic fitness level is so low that they are dependent on other people to help them. Their fitness level is so low that they can't, for example, walk up and down steps. So that is called dependence. We would not like to be in this area. We would like to remain independent. So this line could be people that were not exercising, and where this line are the lifelong exercisers. And here, maybe there's surgery, or maybe someone fell, or something happened. And certainly going into surgery or going into the hospital can be an event where their fitness and is going to decrease. But we would like them to come out of that surgery where they are still independent, where maybe these individuals go through this surgery or through this event or going to this hospital, and now they come out of the hospital and they are dependent. So this higher VO2 max can be a cushion for surgery or disease or some kind of illness. So this outline and this PowerPoint has been a little talk about my research, a little talk about history of exercise, but that led into this paper. That led into this paper on exercise and VO2 max of these 70-year-olds, which is amazing, and the benefits of lifelong fitness. So please skim that paper and look at some of the graphs that I explained, and it is very, very interesting paper, and think how you can relate it to your field of study.